So here are the notes for 2.7 day one. Here what we're going to be talking about the transformations of the parent function to sketch the graph of an absolute value function. So really for this part of the video, we are really just going to see, well, what does the absolute value function look like? And what really happens when we affect it by basically, putting a negative or adding or subtracting values. So that's really what we're going to be getting into today for this video. Now, before we get into that, let's once again talk about absolute value functions, or absolute value, because we haven't talked about functions, we haven't talked about graphing them, but we talked about what they are. So remember, absolute value means it's the distance a value is from 0, and when we take the absolute value of a number, it always turns out positive, because if we think about distance is not negative. So that's why we take like the absolute value of -2, it becomes +2, because 2 is 2 units away from 0. So that's what we worked with, especially when we solved absolute value equations and inequalities. Okay, so let's go ahead, let's kind of graph this one together. So we're going to graph what is called the parent function. So we're going to graph y equals absolute value of x. So this is what we call our parent function. And you might hear me refer back to that quite a bit. So I'm going to just say this is our parent function so we know later on, if I do refer back to it, we know what it is. So basically what a parent function is it's our starter function. Basically, we go off of it, and what we can do is change it by using transformations. Okay, so we're going to graph y equals absolute value of x using the following table of values. So here's how we do it. Just like we've done before, like when you graph linear, quadratic, exponentials, we're going to substitute the x values into the function and calculate the y value. Then we plot the coordinates and sketch the graph, okay? So that means like -2, we are going to plug that into the absolute value of x. So I'm going to go ahead and do it on the side here. So I plug -2 into the absolute value, okay, because that's our x. And remember, when we take the absolute value of a number, it makes it positive. So I should get a +2. Okay, I'm going to do the same thing with -1. So I plug -1 into there. So I take the absolute value of -1, that gives me +1. I plug 0 into there. Well, really, 0 is not negative nor positive, so that just gives us 0. Then I do the absolute value of 1. Though it's already positive, we still keep it positive because 1 is 1 unit away from 0. And then we do the absolute value of 2, and once again, that should still give me 2. Now notice what happens with the y values here, right? I can see that they repeat, and there is a single value that doesn't repeat. Okay, let's go ahead and plot these points. So I go over -2 and then up 2. And then I go over -1, up 1. Then I have 0, 0, which is called our origin. Then I go over to the right one, up 1. And then I go over to up 2. So here it looks like that we make a V shape when we graph absolute value functions, okay? So that's probably something I'm going to put here, because when you graph these, make sure you get that. So basically, absolute value functions make a V shape. So that means you have straight lines and they connect at a vertex. Now, I just used the word vertex, and something you probably haven't heard maybe in a while. What we call the vertex, and this is going to come into hand when we actually graph these, this is basically the lonely point. That's what I like to call it, okay? It is going to be the point where the y value does not repeat. So if we notice 0, 0, this is what we call our vertex, because the y values around it repeat it. So here, that is going to be our vertex, okay? So 0, 0. So now, what I would like you to do, if you notice, there are other graphs. So we have the graphs of 2, 3, 4, 5, 6, 7, 8, 9, and 10. and they are a little bit different. So we took our parent function and included something else with it. So what I would like you guys to go ahead and do is pause this video and go ahead and graph numbers 2 through 10. Okay, and be careful when you're graphing some of these. Don't forget, when you take the absolute value of a number, it does make it positive, but sometimes if you have a negative on the outside, then it will make it negative again. So go ahead, pause the video and do numbers 2 through 10, graphing those functions. Okay, hopefully you paused the video and graph the functions. If there are some that you got stuck on, don't worry, we're kind of going to go over them, okay? Okay, so here is number 2. So what I did is I already plotted out or filled out the table and plotted my points. So make sure you got the same points as I did. So what I did on the side here is show you, well, what would we do when we plugged in our values? So notice that our graph here is y equals negative times the absolute value of x. So let's say I plug -2 into here. Now, when we're doing this, we always want to evaluate what's inside the absolute value bars first, and then we can do stuff that is outside. So kind of think about like with parentheses, right? Our PEMDAS, we evaluate what's inside the parentheses first, and then we distribute the negative. Same thing. So don't distribute the negative first. So how we got -2 here is that we took the absolute value of -2, which gives us +2, right? And then once we took that absolute value, then we actually distribute that negative. So that's how we got the -2. And I did the same thing for all of these. So I took the absolute value of each of these values. So I did absolute value of -1 and then multiply by negative. And then same thing here. I took the absolute value of +1 and then multiply by negative. So that's how I got these values. So definitely be very careful. So notice how my graph is going. It's now facing downwards instead of being up. And notice here, look at where our lonely point is. It is 0, 0. So that is our vertex. And then on the graph, it's right there. Okay, so let's check out number 3 then. And remember, if I'm going too fast, make sure you pause the video, and if you need to get these values down as well as the table and the graph, then make sure you do that. Really, all I did was plot like -2, -2, and that's what I did, and then -1, -1, 0, and then +1, -1, and then +2, -2. Okay, so now let's look here. See how it's a little bit different than our parent function. We have this +2 that is outside. So here are my values that I got for my y. So I got 4, 3, 2, and then 3, 4. Notice that my y values are repeating. So I definitely know that I did this correctly. And how I evaluated is I took my x and plugged into the absolute value. Remember, I evaluate that first. So basically on this one, right, I took the absolute value of -2, which gives me a +2, and then I added 2 later on. So you always want to evaluate what's inside the absolute value bars first, and then, multiply, add, or subtract. Notice where our vertex is. Our new vertex is at 0, 2. And that'll be very interesting to see what's happening there, okay? So there's our vertex, and we can see it here because all the other values are surrounding it. Okay, let's go ahead and do graph 4 then. So here is what I got. We have y equals absolute value of x minus 3. Once again, we have a number outside, but now it's -3, or a minus instead of a plus. So I did the same thing as I did on the other ones. What I did was plug my x value into the absolute value bars. So like I plugged -2 into there. I took the absolute value of -2, which is +2, and then I subtracted from 3, and I got -1. So that's what I did with the rest of these. And notice that my values are negative here, okay? Now if I look and seeing like numbers are repeating, that means basically our 0, 3, that is our vertex. And notice what happened to this. And we'll kind of, summarize everything here. But on the other one, it went up 2 because we had +2. But now since we have -3, it goes down 3. So that's very, very interesting here. Okay, let's go ahead and look at graph number 5 to see if you got those values. Let me go ahead, draw this. So 0, 3 is our vertex. And once again, how I got my graph is I just plotted these points, which we should be able to. And make sure your graph is a V. So it meets at a vertex or a center point, and we get nice straight lines. Okay, number 5. So here, notice we don't have anything on the outside, but now we have something on the inside. So I do the same thing. I take all my x values and plug. Now notice the x values did change, okay? But don't worry about that. We'll talk about how can we figure out what x values to use later on when we actually graph. So what I need to do for all of these is now evaluate what's inside the absolute value. So how I got these values is on the first one, I actually did -5 plus 3. That gives me the absolute value of -2. So I basically combine, and then I evaluate with the absolute value. So the absolute value of -2 is +2. Remember, anytime you take the absolute value of a number, it always turns to positive no matter what, because remember, absolute value means the distance from 0, and distance is never negative. So I did the same thing here. On here, when I did -1, same thing. I do -1 plus 3. I get a +2, and still the absolute value of +2 is 2. Notice where our vertex is. So here, our vertex is at -3. So this is very interesting that our x is -3, but we have x plus 3. And notice where it went to now. Our vertex is no longer at 0, 0, but it's at -3, 0. So that's going to play a role a little bit later on when we talk about our transformations. And remember, the vertex is basically that lonely point in which the y values repeat around it. Okay, let's go ahead and do number 6 now. So here's my number 6. Once again, I have a number inside, but now it's a minus. So just like I did before, I evaluate. So I plug my x into where I see x and evaluate what's inside the absolute value bars first. So I do 2 minus 4. That gives me -2. And then from there, I take the absolute value of -2 to give me a +2. I do the same thing for all of these. Okay, let me show you where if we get a positive here. So I do 6 minus 4. That does give me a 2. I still take the absolute value of a +2, and that gives me 2. Notice here now that our vertex is at 4, 0, right? It's at 4, 0. Boom, boom. Okay, because we can see the y values are repeating around it. And notice where it went to on our graph. It went over to the right. So that's very, very interesting. Okay, let's go ahead and do our 7th graph. So here we've changed it. Now we have a number that is in front of our absolute value. So just as we did it when we had a negative in front of here, we need to evaluate the absolute value first and then multiply by 1/3. So here I kind of just went off just because I did not have enough room to do all of these and show all of them. So here I plug my x values into the absolute value. So like I have the absolute value of -6. What I want to do is take or evaluate that. So absolute value of -6 is +6. And then I multiply by what's on the outside. So I do 1/3 times 6 to give me 2. I did the same thing for all of these. Let me show you what it looks like if we have a positive already in the absolute value bar. So I do 1/3. And the absolute value of 6 is just 6. So I do 1/3 times 6 to give me 2. And notice that my y values did repeat. So I did this correctly. Notice we're back at 0, 0 for our vertex. But if we look at the graph, it kind of changed from our parent function. What happened here is that it looks like it got wider, right? So that's very interesting to see what happens when we multiply by 1/3. Okay, let's go ahead and go to graph number 8. So once again, we still have something on the outside, but now it is an integer 4. As I did before, I just plugged in my value in for x. And remember, I evaluate the absolute value and then multiply by the number outside. So for this one, I take the absolute value of -4. That gives me absolute value of -2. That gives me a +2. And then I do 4 times 2 to give me 8. And I did the same thing for the rest of these. So like for the last one, I take the absolute value of 2, which is just 2, and then I multiply. And if we look, my y values did repeat, so I did do this correctly. And once again, my vertex is at 0, 0. But if we look here, now that our value is an integer or something bigger, notice what happened to our graph. It got narrower, right? It's smaller, narrower than our parent function. Okay, let's do our graph 9. Let's talk about that one. So here we're back to a fraction and we have a negative. Now remember the last time we had a negative, it basically went upside down, right? We have an upside down V. And now I'm kind of seeing a pattern because when we did the 1/3 and now this is a 1/2, it looks like our graph is getting wider than our parent function. So it might mean like any like fractions or maybe numbers below something. It might be like below 1 for right now. Okay, so below 1, it looks like it's getting wider. So this is very, very interesting. Okay, so now let's talk about how I plug these in. So I plugged my x just like I did before. I evaluate the absolute value first. So I do absolute value of -4. That gives me +4, and then I multiply by a -1/2. So that gave me my -2. And I do the same thing for all of these. On the last one, I did the same thing. I took the absolute value of 4, which just gives me, once again, 4. And then I do -1/2 times 4 to give me -2. And notice that my y values repeat, so I did this correctly. And once again, our vertex is at 0, 0 because that is our lonely point. All the other y values repeat around it. Okay, let's go ahead and look at our last graph, graph number 10 here. So once again, I have a negative, but now my number is an integer. Okay, so once again, we know, looks like if we have a negative that our graph like goes upside down, okay? And then maybe if our graph is like an integer or a number bigger than something, it gets narrower than our parent function. So let's talk about how I plugged in my x into this function. So I plugged -2 in for x. Remember, I evaluate the absolute value first. So I do -2. I take the absolute value of -2, which gives me a +2, and then I multiply. So -2 times a +2 gives me -4. And then if I do the same thing here, I have -2. The absolute value of a +2 is just a 2, and I still get -4. And if I look at my table, all the y values repeat, so I know I did this correctly. And once again, my vertex is at 0, 0. Okay, so now that we've looked at this, we have some questions that we need to ask, kind of just to see, well, what are some things that are similar? What do we recognize or observe? So on your paper, you have questions 11, 12, 13, and 14, okay? Now here it says, using problems 1 through 10, answer the following questions. And that's what I would like you to do. I actually would like you to pause the video and go ahead and answer questions 11 through 14 using the graphs of 1 through 10. Okay, hopefully you pause the video and try to answer 11, 12, 13, and 14. We're going to go ahead and go over it. Now, your answers don't have to be the exact same thing as what I have here, okay? So it says, look at number 3 and 4, compared with, of course, number 1, which is our parent function. How does the number after the absolute value symbol seem to affect the graph? So let's go back to 3 and 4 here. So 3, when we had it, is when we had a +2. And if I notice the +2 compared to where our parent function is, so our parent function, we had the vertex at 0, 0. But when we have a plus 2, it looks like I just went up 2 on the y-axis. But if I look at number 4, where I had a minus 3, it looks like I went down 3 on the y-axis. So that's probably what we're going to go ahead and write onto number 11 there. Okay, so here's what I wrote. Basically, as we said, so it kind of made like the graph went up 2, like the entire graph, and then when we had the minus 3, it made the entire graph go down 3. So it does affect our graph maybe vertically, moving it either up or down. Okay, let's think about 12. Now we got to look at number 5 and 6 and compare it once again to our parent function. How does the number inside now the absolute value symbol seem to affect the graph? Okay, so let's go ahead and let's look at 5 and 6. So 5, we have this x plus 3. Now let's go back to our parent function just to look at it. So here, once again, we have our origin, and then here our value, so 1, 1, 2, 2. But if we look here, right, our values, it looks like it shifted, really our x values, they shifted over 3 here. So our y values kind of still seem the same, but it's the x values that were affected, because now we're not going from like -2, -1, 0, 1, 2. So it moved like everything over by 3. Now let's look at number 6, where we have x minus 4. So that was very interesting with the plus 3 that it moved it to the left and not the right. With the minus 4, it seems like, oh, it moved all our x values to the right 4. Because remember, if we think about all our x values for the parent function, right, it just moved it over. So when we have this minus, it seems like it shifted to the right 4. So that's basically what I wrote here. So our x plus 3, it moved our entire graph to the left 3. So the x values did change, if you saw that, and you can always look back at your notes to see that. And then with the minus 4, it moved our graph to the right 4. So once again, our x values changed there. And remember, you don't need to have it the exact same thing as I have, but something maybe similar, or something that also shows that how it's compared. Okay, now we're going to look at 7 through 10 of our graphs and compare it to number 1 and 2. How does the number in front of the absolute value symbol seem to affect the graph? So remember, we had like the 1/3, I think 1/2, 4 and 2 and that stuff. So here is 1 and 2. Now what you want to note is basically probably the y values. So that's something we might want to note. So here's our graph. And then here's number 2, because basically all it did was just flip, but it's still the same like shape and width. And remember, here's our y values for number 2. So we look at 7 through 10. Here, when we had 1/3, notice, and I talked about this, that if we looked compared to our parent function, it looks a ton wider, right? So we have this 1/3 here. It made the graph wider. Okay, when we had the 1/2 as well, right, that also still made our graph wider. So that's very interesting. Now, if we look at 8, where it has a 4, so a larger number, an integer, it made our graph narrower. Like, look how skinny it is, right? So it made it skinny. And then when we had a 2, it still made our graph, you can't really see the effect as much as maybe with the number 4, but it still made our graph a little bit skinnier than our parent function. So what I saw as an observation is that in the number in front, when it's bigger than what I'm going to assume 1, because we had integers, it made the graph narrower or skinnier. But when it was smaller than 1, like we had 1/3, 1/2, and remember the negative, don't worry about that, because all we care about right now is the number in front. It kind of made the graph wider, right? And we're kind of going to talk about why that is so when we get to really talking about transformations as well as graphing these functions. But that's just really my observation. So we'll really have to see if that is, true there. Okay, our last thing is now we're going to look at the sign that is in front of our absolute value, right? So this was numbers 2, 9, and 10. So remember, we saw some negative signs in front. And when we look, right, compared to our parent function always opens up, right? We have a V shape. But we look at numbers 2, 9, and 10 where we have this negative, basically what happens is that our function is now opening down. Or another way of saying it is like it flipped, right? So it's not facing up, it's facing down. It flipped. And we can see that here as well for number 10, that it flipped. So I would say for this one, for number 14, the negative sign flips the graph, okay? So whenever you have a negative, instead of it opening up, we just open down, okay? So make sure you get this done down on your notes, because now, or in the next section of the video, so our next part, we'll talk about, are these observations correct and why? What is happening to our graph, basically to our parent function, when we are changing it, especially with any numbers outside, inside, or the negative sign of our absolute value. Okay, so if you have any questions, make sure you contact me, okay? And make sure you get this done on your notes.